Hi, I'm ready to explain the details of your week 4 program, so let me get started. Um, I've written the program and I will demonstrate it from the user's perspective, and then we'll look at some things that you need to know in order for you to write the program to make this happen. So I'm going to open this with Firefox. And you can see from the title and the heading I have up here that this is a program that allows us to convert from one number system to another, from base 10 to base 2. So as human beings, we represent numeric values in base 10. Most people, I think, believe that is true because we have a combination of 10 fingers and thumbs, on our hands, and that probably when human beings evolved and began to, think about things abstractly, they maybe started counting on their fingers and eventually got to the point where they could represent these things symbolically, and so it only seemed natural to use some combination of 10 different symbols to manipulate things. And so we use the symbols 0 through 9 in various combinations to represent what we think of as numbers that then represent quantities and so forth. So that's what we're familiar with. And in the first lecture I did for this class, I talked about the way a computer works, and one of the things I said was that internally the computer sees everything in terms of high and low voltage states, sees it, in a binary format, electronically in a binary format. And I probably said that, human beings, when they need to get to that level of detail to mirror what's going on inside the computer, they represent that binary format using the digits 0 and 1. Okay, so they use two different digits. Now there's no reason why, I couldn't have used, 1 and 2, for instance. It's just that the convention is that we use 0 and 1, so we'll follow that convention. And what I have then is a program whereby if I enter in a base 10 value, and I'm going to use the value 13 because I'm going to explain some things in diagrams. I'm actually going to use this value, and we're going to look at precisely what 13 base 10 represents. But if I put in a familiar base 10 value of 13 and convert it to binary, then the binary equivalent is 1101. Internally, then that numeric value of 13 could be represented as high voltage state followed by high voltage state followed by low voltage state followed by high voltage state. And I'm going to then reset here. I want you to write your program so that it will check the input from the user, and it will accept the input and work with the input if the input is numeric values, more specifically integer values, in the range of 0 through 1024. 0 through 1024. Okay, so I want you to make sure that the input is integer, that all the characters that make up the input to the function, the parameter value to the function, are integer values, no decimal points or any, otherwise special characters. It needs to be just some combination of numeric values 0 through 9. And furthermore, I want you to restrict the range of that value so that it will be acceptable if it is a value 1 through 1024. 1025 will be rejected and the user will get an alert statement. 0 and anything less will be rejected and the user will get an alert statement. And I've demonstrated how to do that in previous programs, so you can just go back and apply what you've seen demonstrated. But then when you enter in a value, like 1024, it should then convert it to its corresponding base value. You enter in a value of 2, should convert it to its corresponding base value. Alright, so how are we going to make this work? Well, before I get into the details of how we actually do this, the algorithm that you'll need to implement, what I first want to do is take a look at number systems and what they mean, give you some background information. Then we'll look at an algorithm known as the division remainder algorithm, and then the division remainder algorithm will be the basis for your program, the algorithm that you will have to implement in order to make this work right. So I'm going to right click here on the form and view page source. Actually, I don't want to do this yet. Let me skip that and take a look at some diagrams first. All right, so I have 3 diagrams that I'm going to go through. We'll look at the first one. I'll open it in Windows Photo Viewer or whatever it's called. And what I did was I just worked this out on paper, scanned it, and then I will walk through the details with you. So if you're wondering where I got this fancy font, that's the story behind that. And what I want to do is examine a couple of numbers that you're familiar with, 101 and 82. Okay, just pulled those out of my hat. This would work with any positive integer value, and we're going to take a look at what these numbers represent. What is 101 really? 101 is actually, if I dissect this and look at the the value of the component parts, the rightmost 1 represents 1 times 10 being the base, 10 to the 0th power. Now any number to the 0th power is 1, so that's equivalent to 1 times 1, or 1. And then the 0 represents 0 times 10 to the 1st power, base value being 10. Any number raised to the 1st power, any base raised to the 1st power is the base value itself, so that's equivalent to 0 times 10. And then this leftmost 1 represents 1 times the base to the next higher power, 10 to the 2nd power, okay, or 10 times 10, which is equivalent to 1 times 100, or 100. And so that number is really the sum of its component parts. Each component part is represented on a different line here. So if I add these up, if it's the sum of the component parts, I'm back to 101. And you could do the same thing for 82 or any other integer value. So the 2 represents 2 times 10 to the 0th power, 2 times 1. And the 8 represents 8 times 10 to the 1st power, or the base value itself, which is a 10. So it's 8 times 10 equals 80. And if I add them together, I'm back to 82. Now I can apply that same thing to another number system. So let me go to diagram number 2, and we'll take a look at it. And here I have a value 1101. Now you saw that value a moment ago whenever I ran the program, and I told you that 1101 was equivalent to 13. In your program, if you type in a base 10 value of 13 and click convert, it should output 1101. Now, what does 1101 represent? It represents this 1. these add up to, or this is the sum of the component parts, which would be, in this case, 1 times 2 to the 0th power. My base value is 2. 1 times 2 to the 0th power, which is 1 times 1. Any base to the 0th power is 1. So it's equivalent to 1 times 1, or 1. This 0 represents 0 times 2 to the 1st power, base being 2 in this case, and that's equivalent to 0 times 2, or 0. This 1 represents 1 times 2 to the 2nd power, or 1 times 2 times 2, which is equivalent to 1 times 4, and that value is 4. And then this 1 represents 1 times 2 to the 3rd power, or 1 times 2 times 2 times 2, which is equivalent to 1 times 8, or 8. And if I add 8 plus 4 plus 0 plus 1, I get 13. So 1, 1, 0, 1 is equivalent to 13. And you could do the same thing here, and so forth. Okay, so practice this with a few numbers, and what you're going to find out is, depending upon what number it is, then you're going to have to continue to always push the base value to the next higher power, right? All right, so I'm going to close that up, take a look at this third example. And this is an example that demonstrates the division remainder algorithm. So this one is really designed to help you figure out how to write the program. The previous examples were shown just so you could get an idea of how the component parts of a number add up to form the entire number. This is actually showing how to do the conversion, and I'm using a well-known algorithm, not anything that I developed myself, but a standard algorithm known as the division remainder algorithm to do this conversion. Somebody else figured this out a long time ago, and what you'll see is it's an iterative process. I do something over and over and over again. Now, you know about iteration as a control flow structure, and that's why really I'm having you write this program, is just to grind some of this into your brain and help you understand how to apply these things. So it's an iterative process, and you're familiar with two statements in JavaScript that allow you to implement iteration in terms of flow of control. Those two statements being the for statement and the while statement. And we know that the for statement is a fixed iteration pretest loop structure, and we know that the while statement is a variable iteration pretest loop structure. So you need to figure out, which one of these two statements that you have at your disposal are appropriate. Think of it as being, you have some tools in a toolbox and you have a job to do. And if you're driving 10-penny nails or something, you might want to use a claw hammer, and if you're using very small tacks or something, you might want to use a tack hammer. So it depends on the task being performed as to which tool you're going to want to select, and I'll leave that to you to figure out. That's part of what you need to be able to demonstrate when you do this assignment. But the standard algorithm done on paper looks something like this. We need to divide two different ways, one using standard division, the slash operator, and the second form of division that you're going to need to use is what was demonstrated previously with the percent sign, using the percent sign operator or modulus division. So we're going to need to isolate out the quotient and the remainder, the integer quotient and the integer remainder. You'll see how this unfolds here in a minute, but just kind of park these thoughts. You're going to have to, when you actually write this program, figure out which particular looping statement is best to use, for or while. You're also going to have to understand how the division needs to be done in order to be able to keep the integer quotient and the integer remainder isolated. Now, set that aside for the moment, and let's see how I did it on paper, and then you can figure out how to do this yourself. Okay, so this standard division remainder algorithm works something like this. It's iterative. So think of this as being, instead of step 1, iteration 1, instead of step 2, iteration 2, and so forth. Okay, so it's taken me 4 iterations to do this, and I'm repeatedly doing the same kind of thing. In all iterations, I'm dividing by 2. 2 is my divisor. Initially, what I use is the base 10 value itself as the dividend, but that will change. You'll see that with each iteration the dividend is changing. All right. So I initially divide 2 into my base 10 value, and I'm going to need to divide and do something else, and I'll explain this at the very end. I'll use a JavaScript function called parseInt in order to get the integer part of this value, but I'll need to divide. I'll need to get the integer quotient, which in this case 2 into 13 gives me an integer quotient of 6, and I'll have to divide a second time using a different division operator in order to isolate or capture this remainder. So I'm going to have to divide 13 by 2 twice, one with the slash operator, one with the percent operator, to get the quotient and to get the remainder as separate values. Then I'm going to need to take, after doing the divisions, I'm going to need to take the integer quotient, and at the end of iteration 1, take that integer remainder I should have said, take the integer remainder, and I need to post it. I need to stick it out here. Okay, so as a result of step 1, I stick that 1 right here. Then before I go on to step 2, I need to make my dividend something different. Before I go on to the next iteration, I need to make my dividend be equal to my current integer quotient. So once I do that and I come back around the next iteration, I'm going to be dividing 2 into 6. 6 was my previous integer quotient. In this iteration, I'll be dividing 2 into 6, and I'll have to divide twice, once to get the integer quotient and a second time to get the integer remainder. And when I divide and get that integer remainder, I need to take that integer remainder and I need to put it here. Okay. Now, the order in which I take these remainders and stick them together to create this new base 2 value, well, is not an arithmetic operation. That's a string operation. Okay? You're going to have to figure out how to take the result of a numeric operation, modulus division, and stick it out here. Big hint. String concatenation. You'll have to figure that out, though, the details. All right, so I'll concatenate the remainder from the second iteration right here. Then, before I move on to the next iteration, I'm going to have to make my quotient, my dividend be equal to my new integer quotient. So that in the next iteration, I'm going to be dividing 2 into 3, which again was the previous integer quotient, the integer quotient that resulted from the previous iteration. I do that division twice, once to get the quotient, once to get the remainder, and then I'm going to take that remainder and stick it here. Then I change the dividend so that it is equal to the current integer quotient and move on to the next iteration. Do my division, and when I do, I'll get a integer quotient of 0, and that's a heads up to the program to stop. And I'll have to, during that current iteration, also find the integer remainder and post it. So I'll post it right here. But at that point, I'm ready to stop the process. So what is signaling the end? Well, I iterate however many times I need to, and that will vary depending upon the number that's being converted. The number of iterations you go through is variable, and what will control when you stop is you will continue to do the division process and post the remainder until that division grinds the quotient down to 0, at which point you stop, and the number you have concatenated, the string value you have concatenated, will be the corresponding B2 value, base 2 value. Now, I want to say just a little bit more about this division. So I'm going to move over here to just open up a Word document. And let's say that I've got a variable called x, and all right, so I'm just going to write a little code snippet here. I've got a variable called x that I'm declaring here. Word always has to be helpful. All right, so var, please, var x, and we'll let it equal 21 or something like that. All right. So there is an example line of code where I declare a variable called x, and I set it equal to integer value 21. And on the next line, var, it's not going to like var again. Oh yes, it takes it this time. Okay. So I'll have var y be equal to 20x divided by, oh, let's just say 5. How's that? Divided by 5. And on the next line, declare another variable, and I will call this variable z, and I'll let it be equal to x percent 5, and then I'm going to have one more variable, var a, and I'll let it be equal to parse int. This is a JavaScript function. Parse int y. And let's take a look at what would get stored in here. Okay, so if I execute this first line of code, it's assigning a value of 21 to x. Okay, so somewhere down here, let's draw a little box, and the enter key a time or two. Okay, so I've got a variable called x. This is going to represent primary memory here, okay? And again, I'm going to have to go back over here and select this. And x is going to have a value as a result of this declaration and assignment. It's going to have a value of 21, right? And what I'm going to do is copy and drop down here. So the next line to execute would be y, creating the variable y and dividing x by 5 and assigning the resulting value to y. So what's in y? Okay, so y in memory is going to store 21 divided by 5. So that would be, if I'm doing the math right, a quotient of 4 and a 2, 4.2. Let's pretend that's the right answer. Okay. Should have chosen easier values. Okay. So if I divide 21 by 5, quotient 4, bring down to 10, divide, yeah, it should be 4.2. Okay. Then in the next statement, I've got this memory location Z, and Z is going to be dividing the value in X, so the value in X is still 21. It's going to be dividing by 5, but I'm using modulus division, so if I divide using short division, that would give me an integer quotient of 4 and a remainder of 1. So Z should store a value of 1. And then finally, when I declare a variable A, let me create a memory location A here. I create a memory location A, and then I apply this built-in parse int function. That's an uppercase I, everything else is lowercase. When I apply this parse int function using y as an argument, it will peel off the integer part of y and ignore the decimal part of it. So y has a value of 4.2. What gets stored in A is 4. Okay, so you're going to have to do this kind of division in order to get your remainder value so you can post it, and you're going to have to do this kind of division in order to get the quotient value in an integer form so that it can then be at the end of the current iteration, so that it can then be used to replace the current contents of your dividend. Okay, so that is, I think, everything you need to know, and I'll expect you to produce a program that looks like the one that I demonstrated, except that it will, let me go back to that program if I can find it real quickly. So it'll be this program right here. So it should present this interface. Now, if you want to make this fancier, hey, go ahead. Okay, you can add some cascading style sheet rules and, you know, make this look as glamorous as you want. But what I really will be checking is that I have the ability to enter in a value. I have a button that I can invoke a function that'll do the conversion from base 10 to base 2, and that the function will check to make sure the input value is in fact an integer, doesn't have any decimal component or doesn't have any other trashy characters. Not going to be able to enter in R2D2 and have it do anything, but it will check it to make sure that it is an integer in the range of 1 through 1024. And if it is, then it'll allow the conversion to occur, and it should provide the output in another text box. And then have a reset button that works so that you're able to clear out the form from the current calculation and set the cursor inside of the text box, making way for the next calculation. That is your project, and I will be mapping all of this stuff onto Moodle here, but I wanted to try to get this to you as quickly as possible so that you can be working on it, and then I'll have everything updated in Moodle probably sometime tomorrow. All right, good deal.